Obesity and diabetes are also called metabolic syndrome due to disorder in sugar metabolism. Sugar is also called glucose. I will use these two terms interchangeably in this lecture. Glucose by nature is of fuel. That is to say, its principal mission is to burn itself to provide energy for biological activity of the body. Pay special attention to its nature as a fuel. It is a fuel, ladies and gentlemen, exactly like gasoline to a car. How can you neglect oxygen when you consider about a fuel? Unless there is sufficient oxygen always available right there. But as I concluded in previous sections, hypoxia is permeated in modern human life. What if the body falls into hypoxia as seen made by poor RBC quality? I believe you remember the 5 factors of RBC that influence oxygen delivery efficiency of the blood. Without a question, hypoxia must cause disorders to glucose metabolism. However, now in clinical practice worldwide, hypoxia is almost totally neglected while treating obesity and diabetes. If you are one of the patients, have you ever heard your doctor talking about hypoxia? Isn't it a serious blunder? Okay, let's see in detail on this subject. I believe everyone knows about this hormone, insulin, without which cells are hard to take up glucose. Therefore, insulin plays the pivotal role in glucose metabolism. The general rule is the more insulin is out there, the more quickly a cell takes up glucose from blood. Accordingly, the faster the sugar level comes down in the blood. The factors that are influential to glucose metabolism can do so by affecting secretion of insulin. So question is, how hypoxia affects the secretion of insulin? My proposition is that hypoxia stimulates or promotes insulin secretion. I have 2 evidences supporting my proposition. According to a paper by R.C. Soni et al., when people move from sea level to high altitude of 3,000 meters above sea, insulin level elevates markedly. For your information, oxygen content of the air at 3,000 meters above sea is approximately 30% less than that in sea level. It means when you come to high altitude area, your blood carries less amount of oxygen. Accordingly, all the tissue cells across your body are difficult to acquire oxygen as much as needed. It is an experimental evidence that tells hypoxia stimulates secretion of insulin. Next is theoretical evidence that is more convincing. Under hypoxia, cells suffer from energy deficit. In response, cells are intrinsically going to do everything to fill up the energy gap. The alternative is glycolysis. It is the fermentation of glucose, where without oxygen, 1 molecule of glucose contributes 2 units of bioenergy. In comparison, though, the identical 1 molecule of glucose contributes 38 units of bioenergy under sufficient oxygen supply. That is 19 times without oxygen. Do the math. Assume in a given moment, a cell needs 380 units of bioenergy. It takes only 10 molecules of glucose fully oxidized to do the job. However, in case there is a 10% of oxygen shortage, to produce the same 380 units of bioenergy, it takes 28 molecules of glucose, 9 fully oxidized, and extra 19 by glycolysis without oxygen. C, 10 glucose molecules over 28. That's net increase of 190% in glucose requirement. In other words, under hypoxia, cells have voracious appetite for glucose in order to fill up the energy gap. How to help cells in hypoxia take up vastly increased demand for glucose? The answer, definitely high level of insulin. Therefore, by design, it is a mandatory requirement that hypoxia stimulate insulin secretion. Unfortunately, most researches on this subject are mainly without consideration of hypoxia, which is really unthinkable. Keep it in mind, it is hypoxia that requires high insulin level to solve energy deficit, other than so-called insulin resistance that induces high insulin level. Here I have a word on the concept of insulin resistance, which is quite popular among professionals. Weird enough, this concept is absolutely not useful in treating obesity and diabetes in practice. To me, its one and only role is to give professionals an easy tool to explain with least effort, seemingly plausible, the formation of obesity and diabetes. By consensus, insulin resistance means cells become less efficient in taking up glucose under the same insulin level. Since I observed that improved oxygen delivery of the blood is very effective to most obesity and diabetes, I propose that so-called insulin resistance is probably caused by hypoxia through increasing viscosity or stickiness of the cytoplasm of tissue cells, as viscosity lowers the entering speed of glucose. Under hypoxia, insulin level elevates, which in turn helps cells take up increased number of glucose, many of which end up in metabolic intermediaries due to oxygen shortage, other than water and carbon dioxide. With the accumulation of these water-soluble metabolic intermediaries in cytoplasm, intracellular fluid becomes sticky because the more number of water-soluble molecules, the more sticky is the cytoplasm. Uptake of glucose is of diffusion. Keep it in mind, according to diffusion law, the more sticky is the cytoplasm, the more slow is the speed of glucose diffusion. Since glucose enters with a low speed, cells are naturally less efficient in taking up the glucose. Obesity is in essence a result of fat cells storing too much fat. By design, fat cells are better in uptake of glucose than most other cell types under hypoxia due to two advantages. One, it has second most dense distribution of insulin receptors in the surface of their membrane, second only to liver cells. That means fat cells have a more chance utilizing insulin to take up more glucose than most other cells. Two, fat cells use glucose to make fat. That means most glucose molecules absorbed are not ending up in metabolic intermediaries, instead transformed to fat, which can reduce the number of water-soluble metabolic intermediaries in cytoplasm of fat cells, which is obviously good for maintaining lower viscosity. And a lower viscosity is a plus for quick uptake of glucose. Surely, the more glucose uptake, the more fat is made, and the result is obesity. Anyway, my opinion is that so-called insulin resistance has nothing to do with the insulin itself, and it's totally useless. Okay, so much for insulin resistance. Let's back to right track. There is a consensus among professionals that a sustained high level of insulin, or hyperinsulinemia, always accompanies obesity. That's reasonable because high insulin level accelerates uptake of glucose by fat cells, which results in obesity. So identifying those factors that influence the secretion of insulin is the key to the formation of obesity. First, hypoxia. As I just explained, hypoxia stimulates insulin secretion, therefore increases insulin level, which over time causes obesity. We can observe that obese people usually shows hypoxic manifestations such as less energetic, sleepiness, and so on. Therefore, hypoxia is an important reason for the formation of obesity. Second, incretin, a hormone secreted by small intestine, is another factor that stimulates insulin secretion. Therefore, it increases the insulin level, which is obviously a plus for formation of obesity. The persuasive example is probably the case of a gastric bypass surgery, which is reported to be effective in weight management. The surgery excises significant length of a small intestine, which in my opinion unknowingly lowers incretin secretion because the excised length of a small intestine contains many cells that are capable of secreting incretin. Accordingly, incretin secretion decreases, which translates into reduced insulin level. And a low level of insulin is surely effective for weight management. The interesting part is the surgery by design is not reducing the number of incretin secreting cells. The original objective of the surgery was to lower the absorption capability of a digestive tract by means of excising certain length of a small intestine. However, my point is that without lowering insulin level, any means of weight management wouldn't work at all. Think about it. If the insulin level remains high, the glucose uptake by tissue cells remains high too. Therefore, the hypoglycemia is inevitable shortly after each meal. Hypoglycemia means low-level glucose in blood, which induces strong sensation of hunger. And you have to eat a whole lot again, no matter how is the absorption capability of your digestive tract. See, those obese people, they have a voracious appetite for food, which is the result of a hypoglycemia, which in turn is caused by high level of insulin. Therefore, for weight management, manipulation of insulin level is the ultimate key, not the absorptive capability of a digestive tract. By the way, so far, it is not clear how incretin is regulated. Thirdly, epinephrine, or adrenaline, secreted by adrenal glands, inhibits insulin secretion, lowering insulin level, which causes thinness. High level of epinephrine brings about several other manifestations, such as short temper, hyperactivity, insomnia, etc. If you are good on observation, you will find none of these traits is connected to obese people, which implicates that obese people are low in epinephrine. In fact, if anyone is high in epinephrine, they are off from obesity because high level of epinephrine inhibits emergence of a high insulin level, which is a precondition for the formation of obesity. This is a very important point. Keep it in mind. High level of insulin, which causes obesity, is incompatible with a high level of epinephrine. Meanwhile, epinephrine stimulates fat cells to release fat reserve, which is obviously good for weight management. Therefore, certain level of epinephrine is a must condition for proper weight management. Ephedrine, an extract from yellow hemp, has a similar medical efficacy with epinephrine, also able to inhibit insulin secretion as well. It was once a hard sell item for weight management dozens of years ago in America, and banned at the end due to the fact that, like epinephrine, abuse of it induces cardiovascular problems. Okay, to sum up, the formation of obesity requires high-level insulin, which in turn is caused by hypoxia, normal or high level of incretin presumably, and a low level of epinephrine. Now let's turn to the topic of the formation of diabetes. By definition, diabetes is the situation where sugar level maintains at a higher than normal level. Take a look at this diagram. In this diagram, hormone in red ink means it inhibits its target cells. See, only epinephrine here inhibits insulin secretion. Other hormones are all in black ink, which means they stimulate target cells. For regulation of glucose in blood, there are always two sides in work: the side of glucose uptake by tissue cells and the side of glucose supply, mainly by the liver. We should be very clear that while the speed of glucose supply exceeds the speed of glucose uptake, sugar level is doomed to elevate, and the formation of diabetes is unavoidable. The speed of glucose uptake is decided by the insulin level, which is just like we have discussed a minute ago, that three factors work on in concert. What about the speed of glucose supply? Similarly, it is decided by levels of two hormones, epinephrine and glucagon. The higher the level of either of the two, the more quickly liver supplies glucose to the blood. Obviously, to achieve the diabetes, where glucose supply exceeds glucose uptake, there are only two scenarios. One, low-speed glucose uptake combined with high-speed glucose supply. The other scenario, high-speed glucose uptake combined with much higher glucose supply. Let me start with the latter, which exactly coincides with the most prevalent type of diabetes, type 2, and I give you perfect explanation in light of hypoxia. First, high-speed glucose uptake, which requires a high level of insulin. Type 2 diabetes is preceded by obesity, which is caused by high insulin level, as we concluded a few minutes ago. And high insulin level causes high speed of glucose uptake. And high insulin level is caused mainly by hypoxia and low-level epinephrine, as we concluded while we discussed the formation of obesity. Type 2 diabetes are also characterized by susceptibility to hunger and hypertension. High level of insulin helps the tissue cells take up glucose quickly, causing shortly after each meal hypoglycemia, which induces strong sensation of hunger. Severe hypoxia is also able to cause high blood pressure, mechanism of which has been discussed in previous section. See, everything is caused by hypoxia in case of obesity and type 2 diabetes. What about the other side, higher speed glucose supply, which involves liver releasing glucose at a much higher speed to the blood? By analogy, liver is like the oil tank of a car, and the glucose like oil. After each meal, liver builds up a glucose reserve, which is like filling up the oil tank. Like an oil tank supplies oil to the engine, the liver releases a glucose reserve to replenish the blood of sugar, which is continuously consumed by tissue cells across the body. Pay attention to the fact that obese people or type 2 diabetes are susceptible to falling strong sensation of hunger shortly after each meal. Strong sensation of hunger implicates low glucose level or hypoglycemia. Keep it in mind, if liver maintains glucose reserve, there is no hypoglycemia because the liver is obliged to supply glucose to the blood as long as the reserve is available. In other words, hypoglycemia is a result of the liver depleted of its glucose reserve. So we can conclude with obese people or type 2 diabetes patients, liver is supplying the glucose too quickly to be depleted of a glucose reserve within short time. That's exactly the reason why hypoglycemia and a strong sensation of hunger turns up shortly after each meal. See, this is the manifestation of a high-speed glucose supply by the liver, which is only possible under high level of a glucagon or high level of epinephrine. But while we discussed the formation of obesity a few minutes ago, we concluded that obesity is impossible to have a high level of epinephrine. Therefore, the only possibility on table is a high level of a glucagon, which stimulates the liver to quickly release glucose reserve. Here, I have to make a proposition. That is, hypoxia may stimulate glucagon secretion by islet A cells, which are responsible for synthesis and release of glucagon. Okay, let's summarize to have a clear picture. Under hypoxia, on one hand, insulin level is high, which promotes the speed of glucose uptake and causes obesity. On the other hand, under hypoxia, glucagon level is also high, which stimulates the liver to release glucose quickly. But so far, the side of glucose uptake and glucose supply are in balance, both at a high speed, maintaining normal level of glucose. Therefore, up until now, there is only formation of obesity, no diabetes yet. How can the side of glucose supply gain upper hand over the side of glucose uptake to give rise to diabetes? We can find the answer still in hypoxia. Hypoxia over time causes the death of islet B cells, which is responsible for insulin synthesis and release, because B cells are, by design, very susceptible to hypoxia. As a result, insulin secretion tapers off under sustained hypoxia over time. On the other hand, glucagon secretion by islet A cells is not compromised by hypoxia, because not like B cells, A cells don't die. See, over time, insulin secretion tapers off due to the continuous demise of B cells, which means the speed of glucose uptake is progressively compromised, while the glucagon secretion remains strong, which means the speed of glucose supply remains high. This situation must evolve into diabetes over time. Now, we can clearly see type 2 diabetes is possible only after significant number of B cells die away, which certainly takes quite a time. That's why obesity always precedes type 2 diabetes. Assume islet B cells don't die under hypoxia condition, then there will be only obesity, no diabetes at all. Mind you, at the beginning stage of diabetes, patients are still higher in insulin level than the normal people, but the glucagon level is much higher. And it is predictable that at the advanced stage, when the number of surviving B cells is too low, the insulin level may dip less than that of normal people. Then one is to become thinner day by day, but glucose level becomes more difficult to control. Now let's turn to second scenario, where the speed of glucose uptake is low and the speed of glucose supply is high. Although type 1 diabetes belongs to this scenario as well, which is saved of discussing in this lecture. What I'm talking about is a novel type of diabetes characterized by high level of epinephrine. In the past 11 years, I observed that one type of diabetes is quite prevalent, but it seems not covered medically. This type of diabetes are characterized by short temper, not necessarily young of age, normal blood pressure, getting thinner day by day upon initiation of the diabetes. Many of them got the diabetes after emotional trauma, which implicates probably there is an issue of a microcirculation disturbance in certain region of the brain. For the mechanism causing microcirculation disturbance, you may watch previous section. Before initiation of this type of diabetes, one may be obese, but upon onset, one gets thinner day by day. Again, take a look at this diagram. Thinning is an important sign that implicates the patients are low in insulin, which means the speed of glucose uptake is slow. See, this type of diabetes is slow in glucose uptake. Let's see how the three factors that are influential to insulin secretion work to maintain low level of insulin. Epinephrine is the only hormone that inhibits insulin secretion. Therefore, the high level of epinephrine is a must for the possibility of a low level of insulin. I said this type of diabetes patients are in short temper. That is exactly characteristic manifestation of a high level of epinephrine. To achieve a low level of insulin, there wouldn't be hypoxia, because hypoxia stimulates insulin secretion. Yes, sure. Epinephrine is a potent agent for increasing RBC flexibility, which improves oxygen delivery efficiency of the blood. Therefore, hypoxia is off the table under high level of epinephrine. Good oxygen delivery efficiency of blood is helpful to maintain a normal blood pressure as long as the level of epinephrine is moderately high, because extremely high epinephrine is likely to cause diastolic hypertension by excessively constricting peripheral vessels, as observed in the scenario of a chromophene tumor, which secretes extremely high level of epinephrine and also single-handedly induces diabetes as well. What about the incretin, which also stimulates insulin? I'm not sure how is the incretin secretion, but I suppose incretin level should be normal or low. See, moderately high level of epinephrine is good enough to induce many changes, such as low speed of glucose uptake by lowering insulin level, thinning, short temper, and normal blood pressure. What about the speed of glucose supply? Epinephrine is a potent agent to stimulate the liver to release glucose reserve. Epinephrine also stimulates islet A cells to secrete glucagon, which in turn stimulates the liver to release glucose reserve. Epinephrine also stimulates the fat cells to release fat reserve to provide raw material for glucose synthesis at the liver. Therefore, moderately high level of epinephrine is strong enough to boost glucose supply to high speed. See, low speed of glucose uptake combined with high speed of glucose supply. The result is surely diabetes. This type of diabetes is in a sense result of a high level of epinephrine, which is likely caused by microcirculation disturbance in either hypothalamus, which regulates the secretion of epinephrine, or adrenal gland, which are responsible for synthesis and release of epinephrine. I coined this type of diabetes epinephrine-rich diabetes. Okay, now what about the solutions? I observed the method of OTEC is very effective with the obesity and type 2 diabetes patients, as they are purely caused by hypoxia. Once they regain being energetic, which implicates good oxygen supply across the body, their overall health conditions, including the sugar level and the complications, improves significantly. The improvement can be felt in person very vividly. For more information, you may visit my website here, zhuchengtai.net. For epinephrine-rich diabetes, the solution to microcirculation disturbance is supposedly useful, which was described in previous section of formation of microcirculation disturbance. It is expected that a healing crisis is likely to occur at the beginning stage with this type of diabetes, which means temporary rise in sugar level, and you need an insulin injection to control the glucose. Okay, so much for obesity and diabetes. Let's move on to the next section, hypoxia on brain problems.